Okay, that should have been enough time. Now you've restarted the video again. You should have come up with the answer very, very quickly, that as the conductor loop rotates in one revolution, so does the polarity of the current flowing through it. In other words, in that diagram at the top, very, very quickly, you know that the current is flowing away from the observer, therefore we award it what sign? A plus, superb. And if the current is coming towards the observer on the top side of the conductor loop, it's awarded a minus. However, you'll also realise, or you should be able to visualise, that when the conductor loop moves around in that direction, then the polarity also switches between the two sides of the conductor loop. In other words, this side becomes a minus because the current is now flowing towards the observer, and therefore the polarity on the top side switches to a plus. Hence the bottom half of the waveform. That might take you some time to stop and think about it. However, this video is available on the Learning channel, so you can always revisit it there. Okay, superb. Let's clear that very, very quickly. Okay, and we'll move on. You know that from this starting point here at 0 to that point there is one revolution of the conductor loop. Note that one cycle is the interval between any two corresponding points on this graph. So in other words, one cycle can be from there to there, between the two red dots, or it can be from there to there in the green dots. It doesn't really matter where it is, as long as there's two corresponding points and the distance between the two represents one cycle. Make a note. Okay, let's move on. The number of cycles generated in a second is termed the frequency. Let's have a... Rob, you can explain a cycle very, very quickly. Okay, super. If Rob said the number of cycles generated in 1 second or per second is termed the frequency, he's right. In other words, we can represent that by the symbol F, standing for Josh, Tulip, frequency. Super. Well, you also know what the unit for frequency is. You should have known it by maybe the electrics module that you may be studying with Huey upstairs in engineering. Yes, if you identify, it is what we refer to as the hertz. Make it up. You should also be aware of that 1 cycle per second is equal to 1 hertz. We'll make a note of that on the board very, very quickly. 1 cycle per second is equal to 1 hertz. Okay, for the simple two-pole arrangement that we can identify, and you can see in the board on the right-hand side of the diagram, there. One cycle of EMF, right here, all right, there you go.